Hello friends, this is the third lecture and third video on bond order. In the first lecture, we have seen that how to calculate the bond order of the molecules containing up to 8 electrons. In second lecture, we have seen that how to calculate the bond order in the molecules containing 8 to 20 electrons. And in this video, we are going to see how to calculate the bond order of the molecules containing more than 20 electrons. That is, we are going to learn how to calculate the bond order in the polyatomic molecules such as CO3-2, PO4-3, SO4-2, ClO4-, etc. And this video is specially made for JEE and NEET students. To calculate the bond order in polyatomic molecule is very difficult task. Why it is so difficult? The first reason is one should know how to draw the structure of polyatomic molecule. Unless and until we don't know how to draw the structure of polyatomic molecules, it is not only difficult but also impossible to find the bond order in the polyatomic molecules. In this video, I'll give you a super trick to draw the polyatomic molecule structures and how to calculate the bond order in polyatomic molecule. I'm going to explain you step by step. Here we go. Friends, I have taken a lot of efforts in making this video. Please like, share, subscribe my channel. I'm thankful to YouTube and millions of YouTube viewers. There are three methods to calculate the bond order in polyatomic molecules. Two methods are based on formula and they are theoretical methods. And these two methods are time consuming and very difficult. And the third method is super method, that is the super trick. I'm going to explain you how to calculate the bond order of polyatomic molecule by using the super trick. That third trick, that super trick, first I explain you. First I show you, then I go for the theoretical or formula methods. Those two methods also I will explain you in this video. Whichever method you will like, you can follow it. If you go through formula methods or theoretical methods, you require more time to solve and you need to go through more process to get the answer. And if you use my super trick, you can solve the question in few seconds. You can find out the bond order in few seconds if you use my super trick. So I show you super trick first, then I will go for theoretical method. Let us learn to find the bond order in polyatomic molecules. What are polyatomic molecules? Molecules containing more than 2 atoms are called as polyatomic molecules. If you count here in CO3-2, there are 1 carbon and 3 oxygen atoms are there. Total number of atoms in this molecules are 4. So molecules containing more than 2 atoms are called as polyatomic molecules. As I have already told you that to find the bond order of polyatomic molecules, first we should learn to draw the structure of polyatomic molecule. Suppose if we want to draw the structure of CO3-2, first step is we have to find out which is the central atom. I repeat, to draw the structure of polyatomic molecule, first we have to find out which atom is the central atom. How to find the central atom in the polyatomic molecule? The atom which is present in less number, it is taken as central atom. I repeat, the atom in the molecule which is present in less number, it is considered as central atom. In this case, if you see, there is 1 carbon atom and there are 3 oxygen atom. That means carbon atom is present in less number. Therefore, central atom is carbon. So the first step is find the central atom and write it. So here in this case, carbon is central atom and I have written. This carbon is bonded to 3 oxygen atoms. Then we have to write remaining atoms around the central atom. There are 3 oxygen atoms, so write 3 oxygen atoms like this. If you see this molecule, there are 2 negative charges. We have to give 1 negative charge to each oxygen atom. Now, the second step is the oxygen having negative charge must be bonded to central atom with a single bond. I repeat, the oxygen carrying negative charge must be bonded to central atom with a single bond. So I show these with single bond, and the oxygen atom without charge always bonded to central atom with a double bond. This is the structure of CO3 minus 2. I repeat how to draw the structure of any molecule. First, we have to find out the central atom. How to find out the central atom? The atom present in less number is considered as the central atom, and then the remaining atoms should be distributed around the central atom. Then oxygen carrying the negative charge must be bonded with a single bond, and oxygen without charge must be bonded with a double bond to the central atom. In this way, we can draw the structure of the polyatomic molecules. Now I will give you super trick how to find the bond order of polyatomic molecule. Bond order equal to, this is the super trick, bond order is equal to number of bonds around central atom divided by total number of oxygen atoms. This is the trick. Bond order equal to number of bonds around the central atom divided by total number of oxygen atoms. Let us calculate the bond order of CO3 minus 2. Bond order equal to, we will apply the trick. We have drawn the structure already. Now, number of bonds around the central atom. We have to count the number of bonds around the central atom. 1, 2, 3, 4. 4. Divided by total number of oxygen atoms. 3. 4 divided by 3 is equal to 1.33. This is the bond order of CO3 minus 2. Let us consider more complicated and more difficult examples. Let us find the bond order in case of PO4 minus 3. First step, we have to draw the structure of PO4 minus 3. We have to write the central atom first. How to detect the central atom? The atom which is present in less number, that is phosphorus is present in less number, so it is a central atom. Now we have to distribute the remaining atoms around the central atom. There are 4 oxygen atoms, so I distribute 4 oxygen atoms around the phosphorus. There are 3 negative charges, so I can give 3 oxygen atoms negative charges. So oxygen atoms carrying negative charge should be bonded to the central atom with a single bond. So this oxygen is with single bond, and this oxygen is bonded to phosphorus with single bond, and this oxygen is also carrying negative charge, therefore it is bonded to central atom with a single bond or sigma bond. Now I have already told you that oxygen atom having no charge must be bonded to central atom with a double bond. Therefore, this oxygen should be bonded to phosphorus with a double bond. Now, let us apply the super trick to find the bond order in case of PO4 minus 3. Bond order equal to number of bonds around the central atom. Let us count the number of bonds around the central atom phosphorus. 1, 2, 3, 4, 5. There are 5 bonds around the phosphorus divided by total number of oxygens. 1, 2, 3, 4. 4. If you divide 5 by 4, 4 ones are 4, then it will go by 2, then 5. You will get the bond order of PO4 minus 3 is 1.25. Now let us find the bond order in case of CO2 molecule. Carbon is central atom. There are 2 oxygen atoms. We should write around the central atom, and we know oxygen atoms without charge must be bonded to central atom with a double bond. Therefore, this is the structure of CO2. Now let us apply super trick to find out the bond order. Bond order equal to number of bonds around the central atom 1, 2, 3, 4 divided by total number of oxygen atoms 2, that is equal to 2. Therefore, bond order in case of CO2 molecule is 2. Now let us calculate the bond order in SO4 minus 2 molecule. Central atom is sulfur. Then there are 4 oxygen atoms. So I draw 4 oxygen atoms around the central atom like this. And there are 2 negative charges. So I give 2 negative charges to 2 oxygen atom. Each will get 1 oxygen atom. And we know that oxygen atom with a negative charge must be bonded with a single bond. So this is also with a single bond, and the oxygen atoms without any charge must be bonded to central atom with double bond. Therefore, here there will be a double bond and here also there will be a double bond. Now let us apply the super trick. Bond order equal to total number of bonds around the central atom. Let us count 1, 2, 3, 4, 5, 6. 6 divided by total number of oxygen atoms 1, 2, 3, 4. 4. If you divide 6 by 4, you will get 1.5. This is 1.5 is the bond order of SO4 minus 2. Now let us find the bond order of ClO4 minus. Cl is central atom as it is present in less number, so it is central atom, and there are 4 oxygen atoms, so I write 4 oxygen atoms around the central atom, and there is only 1 negative charge, so I give 1 minus charge to 1 oxygen atom, and we know that oxygen atom having negative charge must be connected or must be bonded to central atom with a single bond, and oxygen atoms without any charge must be bonded to the central atom with a double bond. Therefore, these are bonded to central atom with double bond. So now let us apply the super trick here. Bond order equal to number of bonds around the central atom 1, 2, 3, 4, 5, 6, 7. 7 divided by total number of oxygen atoms. There are 4 oxygen atoms, so I write 4. Then if I divide 7 by 4, I get the answer 1.75. Therefore, 1.75 is the bond order of the molecule ClO4 minus. Now let us learn how to find the bond order using the theoretical formula method, and you will come to know how difficult method these are. The first theoretical formula is bond order equal to number of resonating bonds divided by number of resonating structures. That means to use this equation, to use this formula, we should know how to draw resonating structures. The second theoretical formula is bond order equal to 1 plus number of pi bonds divided by number of sigma bonds. To use this formula, we must know number of pi bonds and number of sigma bonds in the molecules. Now let us find the bond order of CO3 minus 2 using these two formulae. First of all, we have to draw the resonating structures. Let us draw the structure of CO3 minus 2. We already know how to draw the structure of CO3. This is the structure of CO3. Now we have to draw the resonating structures. This negative charge will convert into double bond, and this double bond will go to oxygen and it becomes negative charge. So second resonating structure is like this. Then the third resonating structure is this. Negative charge will convert into double bond and this oxygen will become negatively charged. Therefore, the third structure is like this. These are the three possible structures of CO3 minus 2. Now let us use this formula. Bond order equal to number of resonating bonds. You can count how many bonds are involved in resonating structures. 1, 2, 3, 4. That is 4. Therefore, 4 divided by how many resonating structures are there? This is one structure, this is second structure, and this is third structure. Therefore, there are 3 resonating structures. Therefore, if you divide 4 by 3, you will get 1.33. This is the bond order of CO3 minus 2. If you want to use to calculate the bond order this formula, let us use this formula. Bond order equal to 1 plus number of pi bonds. How to calculate sigma bonds and pi bonds? If there is only one bond is present, it is sigma bond. If there is a double bond is present between two atoms, out of two bonds, one bond is sigma bond and one bond is pi bond. If there is a triple bond between two atoms, one bond is sigma and two bonds are pi bonds. So now 1 plus. In this molecule, how many, you take any one molecule, how many pi bonds are there? This is sigma, and here double bond is there. One is sigma, one is pi. Therefore, number of pi bonds 1 divided by total number of sigma bonds 1, 2, 3. Total number of sigma bonds is 3. Therefore, you have to solve this by taking LCM. 3 1s are 3, 3 plus 1, 4 upon 3. 4 upon 3, that means 1.33. 1.33. You will get same answer either by using this formula or by using this formula. But these formulae or this theoretical method is time consuming method, and it takes lot of time, and this is of no use in competitive exam because it takes many because it requires few minutes. But the first super trick what I have given, it requires only few seconds, so you can go through super trick. But for the sake of knowledge, let us take few more examples. Now let us find the bond order of PO4 minus 3 by using these formulae. Let us draw first the structure. Central atom is phosphorus. There are 4 oxygen atoms and there are 3 negative charges. So 3 oxygen gets 1 negative charge each, and oxygen with negative charge should be bonded to central atom with a sigma bond or single bond, and oxygen without any charge should be bonded with a double bond. Now we have to draw resonating structures. If you see here, this negative charge will convert into double bond and this double bond will convert into negative charge. So here there will be double bond. Next time the double bond will come here. Next time the double bond will come here. Therefore, there are totally 4 resonating structures are possible. 4 resonating structures. Okay, I do not draw all those 4 resonating structures, but you can easily understand that double bond is present with this oxygen. Next time double bond will come to this oxygen. Next time the double bond will come to this oxygen. Finally the double bond goes to this oxygen. Therefore, there are 4 resonating structures are possible for PO4 minus 3. So let us apply the formula. Bond order equal to number of resonating bonds. How many bonds are involved in resonance? 1, 2, 3, 4, 5. 5 divided by total number of resonating structures. 4 resonating structures. Therefore, divided by 4. The answer will be 1.25. Therefore, bond order in case of PO4 minus 3 is 1.25. If you use this formula, that is bond order equal to 1 plus total number of pi bonds. Here there is 1 pi bond, 1 divided by total number of sigma bonds, 1, 2, 3, 4. So if you simplify this, 4 1s are 4, 4 plus 1, 5 divided by 4. Again it becomes 1.25. So we get the same answer if we use this theoretical formula or if we use this theoretical formula, or you can use the super trick. Now let us find the bond order in case of benzene molecule, that is C6H6. This is the first structure and resonance take place. The double bonds will resonate and you will get the structure like this. These are the possible 2 resonating structures in case of benzene. Now let us use the theoretical formula. Bond order equal to number of resonating bonds. How many bonds are involved in resonance? 1, 2, 3. 3 divided by how many resonating structures are there? 2. That is equal to 1.5. Therefore, the bond order in case of benzene is 1.5. What does this mean? This means that the bond between 2 carbon atoms in benzene is not either pure single bond or not pure double bond. It is resonance hybrid of single bond and double bond. Therefore, its bond order is 1.5. Now, let us use the second theoretical formula to calculate the bond order in case of benzene. The 1 plus number of pi bonds. If you see how many pi bonds are there, double bond is there, means here is one pi bond, here is second, here is third. 3 divided by total number of sigma bonds, 6. Let us solve this. 6 1s are 6, 6 plus 3, 9 upon 6. That means 3 divided by 2. 3 2s are 3 3s are 3 upon 2 means 1.5. So the bond order in case of benzene is 1.5. Friends, I have taken a lot of efforts in making this video. Please like, share, subscribe my channel. I am thankful to YouTube and millions of YouTube viewers.